11.6.0 What's New webinar. My name is Rodney Corte and I am the product manager for the development of XFdtd, and I'd like to tell you about some of the new features in our latest release. So moving right along, we'll move to the next slide here. Today we'll discuss some of the new capabilities and usability improvements, and then I'll actually do some demos of the two biggest features in this release: the wrapping of geometry as a geometric modeling feature and the wrapping of a PCB, which is basically for flexible circuit application. Some notes to start out with. You should all have a control panel on the left-hand side of the screen where you can ask questions as the webinar proceeds, and we'll answer those as they are brought up or maybe at the end of the webinar. We have Jeff Barney, who is our product marketing manager, on that end taking care of you. So jumping right in, one of the new features you'll see as soon as you start working with models in XFdtd is that we've moved information that was in the status bar of the application or in tooltips of the application directly onto the screen so that you can see them right up front, see what you should be doing at any given point when using the various tools. So for example, in this example here in the upper left, you'll find instructions on how to use the picking tools, tips on the keys that you can press with those picking tools, and if you're inspecting the mesh, you'll also see information about the mesh, such as the cell size and the materials assigned to each mesh edge. In the lower left, the lower right, you'll find information up from the measuring tool and from any tool that reports the position in the geometry. So we're hoping that'll make a lot of these tools a lot easier to use rather than having their instructions hidden down in the status bar. Something that we've been asked for on numerous occasions was the ability to select a lot of small parts with one swipe of a rectangle, like a lot of other tools do. So in this release we've added the rectangle select tool. You just select that tool, draw a rectangle, and everything inside that rectangle will then be selected as shown here. So if you wanted to delete a lot of little components or something, you could easily do that now. Another thing we've been asked a lot about is to be able to create a movie of field sequences. XFdtd has some very powerful visualization of field values both in frequency and in the time domain, but it's been tricky to get a nice movie from that sometimes, and also if you have very large data sets, it can take a long time to visualize those data sets. So with this new capability, what you can do is set up your field sequence in the bottom pane here, which includes setting the start and end of the sequence and some other options about how many frames to skip in each rendering. Then click the Create Movie button and fill out some information about where you would like it to go and what the frame rate you would like to use is. And then click Save, and XFdtd will go off and start rendering the field sequence in the background. You can minimize the application while it's doing that if you'd like, and create a movie at the end that's in a standard video format. I'm sure a lot of you that have asked for that in the past will be happy to hear about this. We've made a slight change to the CAD import workflow as well. In the current workflow, you say that you want to import a CAD file. Then there's a delay while we read information about that CAD file to present in the import options dialog, specifically the ability to show what the width, height, and depth of the model are so that you can choose the appropriate modeling units for that. Typically, though, the person doing this already knows what the modeling units are because you're using the same software over and over again. And so we've optimized that workflow a little bit by letting you tell XFdtd that you know what the modeling units are so that you can proceed directly to the import options. And once you select your import options, then there's a delay while the model is being imported. You'll also see that there's another new box in the import dialog here called Material Assignment Settings. There are a number of options in there, the most prominent of which is to be able to import a bill of materials from Grant to Design's materials database gateway. We'll be glad to answer more questions about that, but that's not really the purpose of this webinar. So just to let you know that we can import bill of materials, which includes material assignments as well as material definitions, and we merge those into the project just like we do with CAD data now. I thought I would mention some other new features and improvements in the application that while they're not major features, I think are important for a lot of people that use our tools. The first two items are interesting because MIMO has been around for quite some time, but with 5G it's becoming more and more important to have proper models of MIMO antennas. XFdtd can produce that data pretty easily, so we have now the capability to export MIMO-specific data for both Wireless Insight, which is another Remcom product, and for MIMOBit, which is a product from a company called Nebens. Both of these tools allow you to do certain kinds of MIMO operations, and I'd encourage you to ask about that if you are in that business. Another feature that went into this release is the ability to define the far zone phase reference on a per feed basis, which is important if you want to measure phase differences between two radiators within the same geometry. We've also added an EM feature called dielectric volume averaging, and that's useful to increase the accuracy of some simulations, such as those for microstrips. We've also updated the software to meet the latest SAR standard. We always try to keep that up to date. We're always asked about it, so I mention it here. There is, in addition to our Circuit Element Optimizer, or CEO, to create a generic RLC circuit. So you can make that arrangement in any way that you'd like and actually define the values of R, L, and C as functions of the other values in that circuit. This will allow you to create a lumped element definition that you can match to pretty much any component that you could find. Additionally, projects will save and load faster, which if you're doing a large project you'll appreciate. And if you're running simulations that are very long, hundreds of thousands or maybe even millions of time steps, we've reduced the number of logging output from the solver to make that output a little bit more manageable. Now, moving on to the major feature for this release, we've added two new geometry wrapping features. And what wrapping is to take one part and conformally map it onto another part. And an area where this is a big deal would be conformal antennas or flexible circuits. So we've actually implemented two features here. One is to be able to wrap a sheet as a modeling operation that's very similar to other modeling operations like blends or Booleans or something like that. The other feature that we've added is the extension of that to be able to wrap an entire PCB design onto a form. So just real quickly, what are the workflows for that? So for the wrap feature, what you would do is go under the Modify button in the geometry view and say, I want to wrap a sheet. And the next thing you'll need to do is select what the source part is, or what it is that you want to wrap. Select the target part, what do you want to wrap it onto, and once you've done that, then you define two orientations, one on the source part and one on the target part, that are meant to align with one another. So when the wrap is performed, those orientations are placed in the same location, and then the wrap is performed from there. So at the end you get something that looks like this for a somewhat complicated structure with multiple bends in it. The PCB wrapping flow is an extension of the current PCB import process. Similar to the wrap feature, you need to define a target and the source. And the source, of course, is the PCB. Since the PCB import is in a separate area of the application, the flow is slightly different than the wrap feature in that you need to select the target before you start importing the PCB. And as part of that, you define a locator. And if you're familiar with XF's modeling capabilities, you might be already familiar with the locator. It just defines a position and directions on any part in the project. And then you go to import the PCB and specify that you want to match this PCB to that locator. And I will be demonstrating these things. So if that didn't make sense, I hope it will by the end. So now I'd like to go directly to a couple of live demos about how to do that, demonstrating these capabilities. So first, I'll bring up a simple case where I have something that might be some crazily shaped substrate for a microstrip, and here I have a strip that I want to wrap onto this part. So what I want to do is I want this end to be down here, and I want this part to extend along the FR4 here, or the substrate. So the workflow is click Modify, select Wrap Sheet, and then I will select the strip. I will then select the part that I want to wrap onto, and remember I'm going to wrap this part onto this part. And the next thing I need to do is to define those two coordinate systems, or two locations. So when I click to the Choose Source orientation, I'll choose the tool to do that, and as I mentioned before, this on-screen display is telling me what I should be doing and any specific information about the tool that I have selected. So I will zoom into here, and I'm going to select the center of this edge and define the normal as up, so that I get a coordinate system that looks like this. The coordinate system that's a little bit shaded here is the coordinate system for the target, and it's not in the right place. So I will want to move over to the Choose Target orientation and perform the same operation here, matching the normals. So I'll select this point, and now it looks like everything is set up correctly. If the U prime or the U axis were pointed in another direction, I could perform my right click on W prime and rotate around to get the directions that I need. So once I have those two orientations defined, I'm saying I want to move this part such that its orientation is perfectly aligned with this orientation on the target, and then perform the wrap. And so I click Preview, and you can see that that is exactly what happened. So I'll click Done, and because these are both sheet bodies, this operation has to happen on a sheet body. There's a little bit of Z fighting here. I'll make this a little bit more clear by thickening that substrate so that you can see that that strip has been perfectly wrapped through all of the bends onto that substrate. So that's great, maybe not particularly useful except for some very specific cases. So let me hide that and show you another example. So this is maybe a more realistic example. Now the situation here would be the same situation that you'd find if you needed to model a flexible circuit. Flexes have been around for a very long time, of course, but they are more and more in use, and it is becoming more and more important to simulate them in an EM simulation for finding out where power is being dissipated or for signal integrity purposes. So the whole reason for this feature is to be able to take a circuit design that's been done in a 2.5D tool and map it onto a form that has been generated by a mechanical engineer. And that's the most typical case. The circuit engineers are generating this thing in 2.5D. The mechanical engineers are saying where does it need to go and how does it need to fold, and we need to merge those two worlds together. And this is how we do that. So just like before, I need to have a sheet, which this is a sheet body, but this is a solid body that I've gotten from the mechanical engineer. Since the wrap feature have sheet bodies, the first thing I'm going to do is I'm going to create a sheet body from the faces that I want to wrap onto on this part here. So I will select this top surface, which folds around here like so, and the edge, and then the bottom part. And I'll click done, and you can see now the gray part is the sheet body from faces I just created. And to be a little bit more clear, I'm gonna hide that solid version that I got from the mechanical engineer. So this is now the shape that I want the circuit to take. And I will click wrap sheet just like before, select the source part, select the target part, and then define these orientations. Now I'm typically picking on the end, but there is no reason that you can't choose anywhere in the design as long as you know where in that design the two parts align. So let me move down to the target, and I'll put that there, and axes are all lined up, everything looks good. I'll click preview, a short delay while XFdtd does its work, and now we now have a complete ground plane, or hatched ground plane with some traces in it wrapped into that form. And I will make that a little bit more clear here by showing the original again and taking a look, and that looks really good. So that's a couple quick examples of the wrap feature. Now, of course, you're saying to yourself, that's great for one layer in my flexible design. I have a design that has 3 or 4 layers with substrates in between them, vias going through it. You know, how is that going to work? Well, that's where the PCB wrap comes into play. So I have a simple PCB design here. It's got some vias and some silkscreen on it that I'll work with for this demo. The first thing I'm going to do is import that PCB so that you can see it flat, so that you know what we're looking at here. I'm just importing this with some options, and I'm going to call it unwrapped. And so that'll come in. I have, you know, it's not complicated or anything, but this is kind of what it looks like. So I have another form. I want to put this onto. I want to import this PCB so that it has a shape that's kind of folded like this. I don't know what the application would be. This is just an example, but what I need to do for my workflow then is, as I described in the slide earlier, is I need to define a locator on this form that I'm going to use when I import the PCB in the next step. So if you've not used locators before, what you're going to do is right-click on the form on a part and say Create New Locator. And I'm gonna name this locator just Form 1, and I'm going to double-click on it to open it. And using our pick tools, I'm just going to choose the simple plane tool, mouse around to somewhere in the middle here, and click. And now I have this locator defined on this form. And in my next step, what I'm going to do is pick a point in this design and then say import the PCB, and the point that I pick on this design will be matched with this locator. And X and Y in a PCB design are always in this plane, so Z or W prime is the normal. So I'll click Done, and now I'll go ahead and import that same design again with the intent of wrapping it this time. So this one I'm going to call Wrapped on Form 1, and I'm just loading options that define the thicknesses of some of the layers and which layers I want to import for this example. The difference is I'm going to go here to the Wrap tab, and I'm going to click the wrap button. And if I have properly defined locators, they'll show up here in this drop-down list. So I see Form 1. So this is saying I want to wrap this PCB to the locator defined by Form 1, and the location that I want to map to it, I'm just selecting something in the middle of the PCB. Of course, you'd be a little more precise if you were actually doing a flexible circuit or something similar. At this point, I'm ready to import. The wrapping process can be a little bit time-consuming, so I'm going to skip clicking cancel. Normally you click OK. I'm just going to cancel this and show you what the result is, kind of like pulling it out of the oven. So here we have this PCB that's been wrapped onto that first form. And I'll zoom in a little bit here to show you that indeed everything has that same curve. You can see the bottom of the PCB is, the first layer is what I actually matched to that form, and everything works up from there. The vias go through, all the pads, all of the silkscreen, everything. If there were traces in this design, they would be there as well. The PCB is just like this PCB that is flat, it's separate, all the parts are separated into their nets and grounds and everything. Exactly the same situation here, with the exception that everything has to that form. And just as another example, this one has been axis aligned with this bend. I just want to demonstrate that you don't need to have axis aligned bends or anything. Any shape will work. Let me go through that process again. I'll right-click, create locator. I'm going to edit that locator and put it smack dab in the middle of this form, and then go ahead and the same process again. I would import the PCB, load in my results and say wrapped on Form 2, and when I come over to the Wrap tab now, I should see 2 locators listed. If I wanted to wrap it onto the second one that I created, I would select locator, choose position that I want to match, and then click OK. And the result of that would look like that. And so you can see it actually has everything kind of nice and swept as I would expect. So something to note about this is that as long as any point on the form geometry only has one axis of bend, all the areas of the incoming design and all the lengths are maintained. So there's no stretching of the wrap feature when this occurs in the plane of the form. If you had something like a sphere, then you'll see stretching or compression in different areas, because there's no way to wrap a flat surface onto a sphere without that. So let's see. I think that actually is a nice, short, sweet webinar. I hope you found some of this stuff that we have put into the application interesting and exciting. We certainly do. Thank you for your attention, and we're taking any questions that you have. And another thing is that we've also got information on all these features under XFdtd customer resources. I can show you what that looks like if you go to our website. Release 7.6 has some more specific demos about doing the wraps, as well as how to create the movies and some of the other features that I talked about here. No questions so far. I guess that's a good thing. If you have any other questions, please feel free to send a message to sales@remcom.com, or give us a phone call, or to support@remcom.com. And thank you very much. Looking forward to giving another one of these webinars soon.